Hello friends, my name is Kanav Bhatia. I am BTech Mechanical Engineer. This is my first presentation. We have prepared a few slides on how you can save RO water at home. Hope these prove to be fruitful to make you aware and motivate to save water. Thank you. Now the next slide would be presented by Mr. Amit Bhatia.
Well, thank you, Kanav, for giving me this opportunity. I'm Amit Bhatia, B Industrial Engineering, and along with me, Kanav Bhatia, we together have prepared the slides project titled Saving RO Wastewater. I would be now taking you through these slides. So slide number 1 is primarily talking of the functioning of a normal RO. Slide number 2 would be giving the details of wastage of water in a common household RO. Slide number 3, we would discuss feasible solutions to save RO wastewater, which would consist of A, basis of design, which is summary of what objective we want to achieve, B, mechanical method, C, automatic electrical method, and slide 4 onwards, we would be showing you the video showing the actual automatic electrical methods working in a house. And before showing you the video for the actual automatic electrical method working in a house, we have also prepared a small slide consisting of only the electrical circuit of the RO system and the overhead tank for the storage of RO wastewater, so that you understand it more clearly. And I'm sure that after going through this presentation, you would not only be motivated to make a similar system at your home for saving of RO wastewater, but also you would understand the functioning of a normal household RO so well that you would be able to do its operational maintenance on your own. So I'm taking you to the next slide. This is the schematic diagram we have made showing the functioning of a common household RO system, which you can see on the right hand side. There's the boundary what we have shown is inside what is there inside the RO system, and outside there's a 25 micron cartridge filter we have put in, to which the tap water is directly fed in, and this primarily cleans the dust particles from the incoming tap water. And from this micron filter, 25 micron cartridge filter, the water is pushed to the inside housing of the RO, wherein the first segment is pre-sediment filter. So water from the filter is fed into the pre-sediment filter. From there it is fed into the pre-carbon filter, and from there it goes to the solenoid valve, which is connected to the electrical float valve fitted in the RO filtered water tank. And from this solenoid valve, the water goes into the RO diaphragm motor and pump, which works at roughly at 75 GPD, which is gallon per day, and 100 psi water pressure. So from here the pressurized water is fed into the RO membrane housing, which has got one inlet and two outlets. One outlet is for the water, clean water, RO filtered water, which is routed through the RO cartridge membrane, and another is the residual water, which is routed to the drain through a restriction orifice. Now you can see the restriction orifice on the red line. It primarily is a fixed flow control valve kind of a thing, which gives a back pressure onto the RO membrane so that you can control its TDS. TDS is total dissolved solids particles in the filtered water. Generally in a household RO, with respect to the 25 micron cartridge filter water TDS to the RO filtered water TDS, there's a difference of roughly 1/10. So supposingly tap water is roughly around 700 TDS. So after cleaning from filtering from the RO, you would get roughly around 60, 65, 70 TDS. So that is the kind of filtration it does. Then this system works on household single phase power supply 220 volts, as you can see in this schematic diagram, which is fed into the 24/36 volt DC adapter. Here in this schematic diagram I have shown 24 volt DC adapter. From there, one line, positive line, is directly connected to the solenoid valve, RO diaphragm pump and the electrical float, and the next negative line is given through the electrical float fitted in the RO filtered water tank, which goes to the diaphragm, motor and pump and solenoid valve. So once the RO filtered water tank is full, it cuts off the power supply to the motor and pump as well as the solenoid valve. Now for the filtered RO filtered water, it goes into the tank fitted into the household RO system only, and in between the RO membrane housing and the filtered tank we can also put, as per our convenience, and some of the suppliers do it also, that they can put a mineral cartridge or a after carbon filter cartridge, so that your, as they say, that the final RO filtered water is not only TDS control, it has got its desired mineral back also. So as you can see in this slide, the RO filtered water tank is full and the electrical float valve cuts the power supply to the solenoid valve as well as the RO diaphragm, motor and pump. You can also see from this slide that the ratio between the clean water and the wastewater is generally 1/4 is clean water and 3/4 is wastewater. So supposingly you are getting say 80 liters of water for cleaning in a day, so you would get roughly around 20 liters as clean water and 60 liter would go waste, and it will go into the drain as the wastewater. So this is our prime objective. This is the water we want to save as much as possible. So we'll go to the next slide. So it is evident from the previous slide that due to the RO function, a common household RO wastes a lot of water. It is roughly 40 to 50 liters per day per RO for a single household. Now in the next slides we'll learn how to build a system to collect this wastewater and use it for another household jobs such as washing utensils, cleaning clothes, cleaning floors, etc. Now we come to another slide wherein we are talking of basis of design. Basis of design is primarily writing down what we want before we make a system. And here what we want is A, to have sufficient and continuous flow of RO clean water, and then that is for our potable purpose, and then B, to have a system to save the residual wastewater as much as feasible. C, to reuse and collect wastewater for washing utensils and other household works. To satisfy above, we have designed a system, mechanical as well as automatic, for collection of wastewater as much as we have capacity for storage and usage for washing utensils and other household works, and let the residual water go waste, with definitely with a further plan to increase storage capacity and utilization for wastewater to minimize. Next slide. Next slide, you can see in mechanical method what we can do is in the wastewater line only we can put a wastewater bucket for collection of the wastewater with an overflow pipe fitted into it, so that when the bucket gets filled and we are not able to utilize the filled water totally for household jobs, the water doesn't start spilling on our floor and doesn't start spoiling our kitchen. So it should have a overflow pipe wherein it pushes the spilled over water in the sink, so that there is no spillage of water in the kitchen and doesn't spoil the hygiene of the kitchen. This is the slide showing the schematic diagram for the automatic method. Here you can see in the wastewater line we have put a solenoid valve, another solenoid valve 24 volts, and we have put an overhead tank which can be fitted onto the wall, or if your kitchen has got sufficient cabinets, we can have a water tank installed inside the cabinet also, so that it looks tidy. And this cabinet can be fitted with solenoid valve, which is NO float valve, normally open float valve, which once the wastewater would first go into this overhead tank. Once the tank gets filled, this NO float valve will go to the circuit close point, and it will complete the circuit for the solenoid valve, which would drain the water the way it was doing before putting the overhead tank again back to your sink. And what we can do is, from the collected storage tank, overhead water storage tank, wastewater storage tank, we can again, on the extreme right, you can see a red line again, red pipeline to kitchen sink tap, so that we can directly utilize this collected wastewater for our kitchen utensils washing and other household works. Now this is the slide showing the schematics, electrical circuit diagram for the RO inside housing, and also for the overhead wastewater storage tank, wherein NO valve, float valve has been fitted. So you can easily understand that the inside RO solenoid works with the in series with the electrical float for the water storage tank, for the clean water tank, and the outside NO float valve and solenoid valve, which is shown with a red arrow at the bottom right side of the slide, that operates with the NO float valve fitted onto the wastewater storage tank, overhead tank installed in a cabinet. So it's very easy to understand with this slide how the electrical circuit has been done. The input supply is 220 volt AC common household single phase supply, and from there it goes to the 24 volt DC adapter, and from there the positive lines are directly fed into the both the solenoid valves, for the inside solenoid valve through the electrical float, and for the outside solenoid valve for the wastewater drain line through the NO float valve. I think it clarifies the entire scheme. Now this is the slide which is reiterating our objective to save water and save earth. How? By reduce, reuse and recycle. Thanks. Next slide you would see the video showing the actual working of an automatic overhead tank system in a household. Thank you very much. This is the movie clip showing clearly a household RO installed with the overhead water collection tank fitted with the electrical NO float valve. So you can easily see overhead tanks fitted in a cabinet with a float valve, you can see, and the outlet of these storage tanks given to the tap line, which feeds the sink tap for washing utensils. So as you can see, when the overhead tanks are full, the outlet wastewater is going through to the drain through the red pipeline, RO wastewater pipeline, and once we open the tap, the overhead storage tank slightly gets emptied and the water starts storing in that, and red line stops. This is the last slide showing the summary of what we have learned till now. By the time we do not get graduated to install an overhead storage tank fitted with electrical float and solenoid valve, at least we should start keeping a bucket with overflow pipe and start reusing the RO wastewater. Moreover, it's not very difficult, rather it's very easy to go in for the overhead storage tank with an automatic float and solenoid valve, since these float valves and solenoid valves are easily available at all popular internet online shopping sites. Thanking you once again, Amit Bhatia and Kanav Bhatia. For feedback, please write us to kanavbhatia1997@gmail.com.